4.5, integration by substitution. Okay, so a little fuzzy. We have anti-differentiation, which is a reminder of that word also means you're integrating. Those are interchangeable for the same thing. Of a composite function, meaning a function inside another function. So remember when we did derivatives of composite functions, we called it chain rule? Essentially, we are opposite chain ruling. So if you look at something, you're like, oh, I would chain rule this if I were deriving, then that means you're going to do this method for integration. Okay, chain rule does not exist for that, but there is a process to it. So we have all this crazy stuff, but what I want you to look at is it shows a composite like f, it shows the chain rule. Like I have f of a function times the derivative of that function, that's chain rule. If I'm integrating that, I get whatever capital F of g of x is, okay? So we just have to figure out what that is. Now, what we do is we let u equal the inside of the function, and we will practice this, I promise. Then we'll get du as the differential of that. You'll write as a differential, okay? And then you substitute in. So in place of du, this goes in place of du, and f of u goes in place of f of g of x. You'd substitute in, and we'll see what that looks like, and then plus c. So we'll start with indefinite integrals, which means you don't have limits of integration, and we'll move to definite integrals. And that's kind of where it gets a little hairy sometimes. All right, so starting here. All right, we have f of x squared plus 1 squared times 2x dx. If we were to do this prior to learning this, you would have to square x squared plus 1 and then distribute the 2x and then integrate it, which on this problem wouldn't be a big deal. But if it was bigger powers, it would be a big deal. And so what we're going to do is you'll do u substitution. I can tell it's a composite. I can tell that the inside function is the antiderivative of my outside function, or the outside function is the derivative of my inside function because it's x squared and x. Okay, they don't have to have the coefficients matching up, but they have to have the powers matching up. So what we start with is we're going to let u equal the inside, the very most inner part of this integral, which would be the x squared plus 1. Not looking at the integral, I will now take the derivative of u so I can do the differential. You do not look at the integral for this. If it matches, great. If it doesn't, you make it match, but you have to do it on its own. So I'm looking at just u equals x squared plus 1. I'm doing its differential. So the antiderivative, or the derivative of x squared, is just 2x, and you're doing a differential, so dx. Okay. So this is back what we did before Christmas break. Now you're going to substitute in. So I'm going to rewrite this as the integral of, and if you notice, this x squared plus 1 is my u, and my 2x plus, or 2x times dx is my du. So everything that has an x is substituted. You can't mix and match. So everything needs to be just x's, or everything needs to be just u's, but you can't mix and match. The squared is no problem, but we notice we're not substituted in for that squared, this squared here. He's still there. He's not substituted in for. So when I plug in my u, it is u squared. In place of 2x dx is just du. So we have substituted in everything that could be substituted in for, leaving u squared du. Okay. Then I'll just integrate like normal. So increase the power of u squared, and divide by that power. What will I get for the antiderivative of u squared? Okay, 1/3 u cubed. Very good. And then we always remember our plus c. You don't get to circle that answer. Because it asks for antiderivative of something with x, your final answer needs to be something with x. So all I have to do is, I know what u is. I substitute it back in. So I have 1/3. Instead of u, I now have what u is equal to, x squared plus 1 cubed plus c. That is called u substitution. Now, mentally do this. You're going to do the derivative, chain rule. If I were to take the exponent and multiply it in front, I would have 3/3, which is 1, right? Keep the inside the same, x squared plus 1. The exponent would now become 2. Then I would multiply by the derivative of the inside, so the derivative of x squared plus 1 is 2x. That is exactly what they gave you to start. So you can check your answers. So do that, always. All right, let's do another one. I know it's a composite because I don't have just x up here. And I would have to chain rule this if I were doing the derivative, which means I'm going to have to do the opposite chain rule for antiderivative. Okay, they call it the antidifferentiation composite rule, but we can just call it opposite chain rule. All right, so we will let u equal that innermost part, 5x. So du is equal to, the derivative of 5x is just 5 dx for a differential. Okay. If you look, I have u going to be substituted in there, and this 5 and these dx together makes up for my du. So everything entirely is substituted in for except for the e, which is no problem because it doesn't have it is not a variable. So integral, keeping my e because I have not substituted in place of e. Instead of having e to the 5x, I will have e to the u. Instead of having the 5 in the dx, I will have just du. The antiderivative of e to the u is really hard. It's e to the u. I was being sarcastic. However, if you're asked for antiderivative with x's, you need to return your answer with x's. So we'll do e to the what? What is u? 5x plus c, and that's your answer. You have to do plus c because you don't have limits of integration. So previous section, we had limits of integration. We didn't have plus c because we found actual values. Okay. Any questions on that? We're going to do more, I promise. It's one of those things I feel like if you can keep doing it, you'll get the hang of it. Okay. More indefinite integral. In this time, whenever we do our derivative, our differential, it's not going to match perfect. We'll have to then manipulate it in order to make it match. So before it substituted in beautifully, we didn't have to worry about it. It's not. Okay, we'll have to do some work with it. All right, so I'm going to let u equal, what would be the most inner part of this? Make sure you guys are able to identify that. X squared plus 1, good. And the derivative, the differential of x squared plus 1 would be du equals 2x dx. Now, I don't have, like this is substituted in for u, but I have to be substituting in for the x and dx, but I have 2x dx. I don't have x and dx. What can I do to 2x dx to make it x dx? I am going to multiply both sides by 1/2 so that I actually do have x dx on the right. So I have 1/2 du equals x dx. So in place of that x dx, I'm actually not substituting in one or du, I'm substituting in 1/2 du. Okay, so when I write this, now, the 1/2, it would look really silly if you did u squared 1/2 du. If you have a constant that you have had to multiply or divide to make it balance, you can actually put it in front of your integral, okay? Any constant that can happen to. If you want to do that from the very beginning, say there was a 6 in front of that x, you could automatically just move that 6 outside that integral, just don't forget about it. But it's a constant, so constants can be moved out. All right, so we'll have 1/2. In place of x squared plus 1, I put u squared. In place of the dx is where we have our 1/2 and our du. Okay, so everything's been substituted in for, but instead of writing u squared 1/2 du, we pulled the 1/2 in front. All right, so then keeping my 1/2, saving it for later, I need to integrate u squared. So I need to increase my power by 1, divide by my power. So what is the antiderivative of u squared? Hint, we already did it. What is it? 1/3 u to the third. Very good. Plus c. So that 1/2 is still there, so just don't forget about it. Simplify, and I will get 1/6 u cubed plus c. Then don't forget, we need to make sure we go plug in for u, and we know u is x squared plus 1. Which, if you were to do this derivative, you'd have 3 times 1/6, so you'd have 1/2 x squared plus 1 squared, then times 2x, which would take care of the 1/2 that's at the beginning, leaving you with just that x. So it does work out when you do your derivative and balance it out. Any questions on any section of that? Okay. One of the hardest things, I think, is we were doing 2 things in one problem. You are deriving and you are anti-deriving. So just make sure when you're supposed to be decreasing powers, you're doing that. When you're supposed to be increasing them, you're doing that. Try not to mix them up. Okay, next one looks super complicated, but I think it's important to recognize that this is the same thing as this. Okay, those are identical. Okay, that squared where it's at on that sine squared 3x also means sine 3x all squared. Okay, so if we are doing this for the opposite chain rule, we're going to let u equal what is the most inner part of this antiderivative? Sine 3x, good. So then du is going to be the derivative, the differential of sine 3x. So what is the derivative of sine? Cosine. And we're going to chain rule this because it's not just x on the inside, it's 3x. So we will have cosine, keep the inside the same, times the derivative of the inside, which is just 3. I'm going to put that 3 in front. And then we're writing as a differential, so dx. So you had to chain rule it. So the derivative of the outside was the cosine, keep the inside the same, 3x, times the derivative of the inside, which is where that 3 came from, but instead of writing it at the end, I went ahead and wrote it where it should be in front. Now, it is supposed to be, if you look, this is u, and I have to make my du some version of this, except for my du is 3 cosine 3x, and I need it to be cosine 3x dx. So how do I get rid of this 3? How? How? But multiply by a third. Yeah, so to get rid of it, you got to do an opposite operation. So you're going to divide both sides by 3 or multiply by 1/3. I'm a little weird, and I like to divide the one side and then multiply the other side so that, I don't know. I don't want to write it 50,000 times. So you got to get rid of it. You do have to move it, but make sure you use whatever the opposite operation is. So if you're going to have to divide or you're dividing or multiplying basically every time. Okay, so at this point, I've been dividing, but they could give you something where you just, I need to double both of them to be equal. All right, so then this will be 1/3 du in place of all that. So, like Emilio said, we're going to put our constant out front. So my 1/3 has been moved out front, but I'm going to now have u squared du, which is funny because we've now integrated u squared du. This will be the 3rd time, but they didn't look anything alike from the beginning. Especially this one. This one looked way different. Like I bet you wouldn't have thought that's what you'd be integrating when you saw it to start off. All right, so the antiderivative of 1/3 u squared du is 1/3. That's the original 1/3, but then I will have another 1/3 because the antiderivative of u squared is this guy that we've used now will be for the 3rd time. So I have 1/9 u cubed plus c, but in place of u, I have to go plug in my sine 3x. So you can write it like that, or if you would rather put the sine 3x in parentheses and cube that, just make sure you're not cubing the 1/9 as well. So you could write it like that, or you could write it like that. Okay, that's kind of up to you. This is probably how you will see it most of the time in your text, though. Any questions on that? Okay, keep on moving. All right, here's a bunch of practice. Whatever we don't get finished today, we'll do tomorrow. All right, so I see an obvious composite because I have function inside of a power. Okay, so you're going to be looking for things to be inside of trig functions. You're going to be looking for things to be inside of powers, inside of roots, something that makes it a composite. So in this problem, I'm going to let u equal, I'm going to zoom in a little more than that. What? 3x minus 1. So du is 3dx, which is actually great because this is my u and there is my du. Perfect. So I don't have to worry about dividing or multiplying to make it work out. So I will have my integral of what? I want you guys to try to plug stuff in now. U to the fourth du. Because this whole thing together is du. Good. What is the antiderivative of u to the fourth? 1/5 u to the fifth. You're increasing the power by 1, dividing by that power, plus c. Equal to, and what's my final answer? Plus c. Very good. Whatever you do, don't forget that plus c.
Where did we use the 3dx?
We use the 3dx. See how I circled here the 3 and the dx? And that's equivalent to du. So when we plugged in this du here, that's where that happened at.
Okay, we don't really just plug it in for anything?
No, we did substitution. So in place of 3dx, it became du. Even though they're separated, remember that multiplication is commutative. You can rearrange those any way you want within the multiplication. Like I can't get inside the parentheses, but I can still rearrange the parts of the product. Anyway, so that 3 and du together make up, or 3 and dx together make up the du. Good question. All right, a little harder. Ish. Well, it's not really that too bad. All right. Here's the thing. If you pick a u and it doesn't work out to substitute at all, like you can't figure it out, maybe pick a different u. Okay? I'm just going to throw that out there because this next one, I feel like you can kind of look and like, they're not very different. You might pick the wrong one to start, but then you should quickly realize that it's not going to work out. All right. So on B, it is a composition because it's a product. And I guess you could distribute it if you wanted to, but it also works with u substitution better. We'll call this method u substitution, actually. In some textbooks, that's actually what it's called. All right, so we're going to let u equal, any guesses? The second one. What made you think that, Emilio? Because you're right. Because if you notice, if I just kind of picture, if I'm deriving that one, I have an extra variable, which would then result in the one written before it. So I'm going to let u equal e to the x plus 1, so that my du is equal to, well, the derivative of e to the x is e to the x, and my derivative of x is just 1 dx. So
Chase Bachowski, please come to the office.
So this guy will replace with u, and these two things together will replace with du. Okay. So then what will this integral be? Anyone brave enough?
U du.
It is u du. Awesome. So the antiderivative of u is
1/2 u squared.
1/2 u squared plus c equals 1/2. Replace u with what u is equal to, which is that ex to e to the x plus c squared. So even though it didn't really look super composite before, if you look, it is part of what was a composite function. The problem with if you would have distributed this out, you would have had a really hard time anti-deriving it. But you would realize that quickly if you did it, because you're going to have a hard time doing the antiderivative. Well, no, it wouldn't. You just have more use substitution. You have to use substitute several different sections of it is what you'd have to do with what you distributed. Okay, let's look at C. Let U equal what? X cubed minus 2, perfect. Du is going to be 3x squared dx. So if you notice, that's my u, and that together is my du. Good? So what is this antiderivative when I rewrite it? Any ideas? If you look at the part that we're not substituting in for, it's the square root. So the square root will still remain. And then we're replacing what's inside the square root with u. So we have this. Which actually, here's the thing. If I were doing this problem on my own, I wouldn't even write that. I would write 1/2. Exactly. That's what I would do. I would automatically go from one to the other without doing so many steps. But it depends on your brain. And if you need to see that, then you should write that down. And it's not a big deal. Okay, so then we do the antiderivative of that. It's not as pretty as before, but we'll increase the power by 1 and then divide by that. Keeping in mind, when you divide by a fraction, it's the same as multiplying by the reciprocal. All right, so what is the antiderivative of u to the 1/2? Very good. 2/3 u to the 3/2 plus c. So I increase power by 1 divided by 3/2, which means I multiply by 2/3. Then I'm going to go ahead and plug in my function. And I will have 2/3 x cubed minus 2 to the 3/2 and plus c.